Oh, yeah. All the worksheets we've done recently. All right, guys, so that number 5. Okay. Yes, sir.
What happen we can't solve equations?
So I want to devote a decent amount of time to how to solve equations because that's the bread and butter of algebra. Like word problems, you have to set up your own equation, but if you can't solve it, you can never get the answer. So it is important to learn how to solve equations, and if you need, like I said, you can come to me for help. I'm trying to do as much in class as I can because quite a few of us still don't feel as comfortable with this as I want us to before we get into word problems, right? Word. I often like to do this. Now, when you look at this, what's your immediate reaction?
Yeah.
Run away.
Yeah. I like that. Let's get the question. Erase it. Hope I don't notice. Oh, I didn't realize it was part of the homework, Jeff. Sorry. But what I desperately want you guys to realize is, at worst, this problem will take longer than a smaller problem. That's it. It's not harder. It's just got a lot of crap in it. And if you need to develop the ability to only focus on one piece of this at a time. The more comfortable you are, the more you can do it once, and that'll make the problem go a little bit quicker. Right? So, for example, go look at that for a second. If I wrote this here, just like I said, simplify this, what would you do? How do you simplify?
minus 3x.
I love it. So what property is that? Distributive. Because you distribute the 3, so 3 times 5? 15. 3 times negative x?
X.
Negative 3x. How's that? Is that cool by itself? Do you notice that that is, of course, a piece of this problem? So that piece is that simple, right? So you let the parts be simple. You bring the rest of it along the way. You don't freak out the minute you see more than 5 terms somewhere or something, right? So the only freaking out is not really a freak out then. It's like, oh man, this is going to be a long problem. It's not, holy shit, what the hell am I going to do with this? It's a different kind of thing. So for example, what can I do on this side? Notice there's my equation, right? That's okay with me, but then it looks like it says not equals 2. That's no good. But that's my equation. That's the separates the sides. What can you do on this side first?
6.
8.
Careful.
4. 6x.
Yeah, distribute that 2.
8.
Yeah, 8.
Negative.
Minus 4x. And the minus x is still there. So far, so good? Yeah. So notice how I didn't care about the 6x. I just brought it with me. I wrote what that was, and then I brought the negative x down. Yeah.
32. 4 is 4, then 2 is 4.
So are you talking about like this and this, maybe?
Yeah, 8 minus 4 is 2. Is 2.
Careful. No, careful. What's the only term up here that's not like with the rest of them?
X.
8.
8. Notice, Randy, watch this. Don't each of these have an x in it?
Yes.
So you can do 6x's minus 4x's is how many x's? 6x's minus 4x's.
4.
6 something minus 4 something is how many?
10.
No. If you had 6 apples and I took 4 of them,
2.
2. I love it. So 6x minus 4x is 2x.
Minus
It's 10x.
I'm with you. Don't worry. We'll do 2 things at a time. See, now you can start combining like terms. Let me not forget about this other side here. So notice, I don't care how big I make the equation. What do you almost always do first? Distribute. Why do we do that? So the parts are free to move around. So I can put my like terms together because that's the next thing I want to do.
Isn't that x part of the 6x, 4x?
I left it there. You don't have to do all the x's at once. I can do 6x minus 4x is 2x. That minus x is still there. You with me? Now listen, I only did that because of the explanation I was trying to make.
All right.
Now, in reality,
it's still a like term.
you could do 6x minus 4x is 2x minus x is x. I'm still going to get that, right? I'm still going to get that just later.
Okay.
Yeah.
Not 1x.
Eventually. I'm with you. That sounds good. What happens on this side? We already did this. And now the rest of it's still here. So for some of you guys, I know I'm not the neatest person in the world, but some of you are even less neat than I am. Right? So you desperately have to be very kind to yourself. Do not be evil to yourself. Math is hard enough. Don't make the whole problem the fact that you can't see what was where. You want to be very organized. Do something, but leave everything else there. I see way too many people trying to do a part of the problem and then try to bring it back together. You almost always lose something or put something in the wrong place. All you have to do is keep bringing everything down with you. This equation, is it different from this equation?
No.
No. Why'd you say that?
Because I just guessed.
Because they're the same thing. It's just like saying, is 3 plus 5 different than 8? No, they're two different versions of the same number. So if you do something like this, you haven't changed the equation, you've just written it a different way. Let's see, what can I do on this side? What are like terms?
15
plus 2.
Good, 15 plus 2?
17.
17?
And
plus
12.
Careful, you're not multiplying.
1x.
Yeah, negative 3 plus 4?
Plus x.
1x, I like it. All right, negative 3 plus 4 leaves you a positive 1x. You're not multiplying, Randy, right? You're adding. So negative 3 plus 4
Okay.
is 1. Good. Just like over here, what'd you tell me this was? 2x minus x?
4.
No, what's 2 something minus 1 something?
2.
2 minus 1?
2, 1.
1. So your 2x minus x is x. Okay, so up to this point, everything you can apply everything we've done to any equation. Now, I don't know if you guys tried this. Anybody try this and get to this point?
Yeah.
And then the next point, of course, freaked you the hell out? Because what's the next step here? Are my x's together?
Yeah.
They are together.
No.
No. Good.
We will.
How do you cancel this x out? Minus x. So what do you have to do to the other side? Same thing. What do you get? And then you go, oh my God, let me go collect my Nobel Prize. I've just proven that 8 is 17. Right? No, that's crazy. So then listen. Listen. I want to bring this to the real world for a second. If you work for a company, and your whole thing is to figure out the equations that come up with the profit for your company, and you're a tiny company, you're just barely bigger than a freaking lemonade stand. You with me? Stupid little company. You sell banana ice cream on the side of somewhere. Right? Who likes banana ice cream? So your boss comes over and says, can you figure out in your equations what we have to do to make $8 billion next year? Right. Do you think that's possible, considering the scenario I just set up? Can your company make $8 billion next year if it stays? No, you with me? So if you put that into an equation, the math has to have a way of telling you that's shit. That ain't going to happen. Math has to have a way of telling you the equation you wrote is bogus. So if I try to write an equation for my little tiny company to make $8 billion, I do the math, it's going to somehow tell me that's bogus. It's not going to say, that's bogus. It's going to say, all right, your equation is good if 8 equals 17. Does 8 equal 17? No. Then this equation is bad. There are no solutions. This is math's way of telling us that our equation was bad to begin with. There is no way to make this true. That's what this means. So this would mean no solution. And just to really highlight this, give me 1 second. Let me solve a really simple little equation. How do you solve that equation? Yes, sir?
This plus 1 equals x7.
Now solve it, though. What would you do? I love it. You got the answer, but how would you solve it? What would you do to both sides?
1x, 1.
How do you kill this 1?
6.
Subtract 1.
Subtract 1.
When you solve an equation, you want to get x by itself. So how do you get rid of the 1?
X.
Subtract 1. And see, this is your 6 that you told me, right? You with me? Got to be careful. You got to show me the steps. Don't just have the number come out of nowhere. You got to show me this. Now, the reason I did this little dinky equation real quick has not a damn thing to do with this. You with me? And if somebody's out there like, how would I know to do that? No. It's just a separate example. What this means is, when this is true, then this is true. That's really what it means when you solve an equation. So when x is 6, then x plus 1 is 7. Does that make sense? If you plug a 6 in, what happens? If x is 6, 6 plus 1 is 7. Good. So look at it this way. When 8 is 17, then bleh equals bleh. Right? I don't want to say it all out too long. Or you can always say that at the end of any equation you solve. When this is true, then this is true. When is this true?
When this is true.
When is this true?
When that is true.
Help me, God. When is 8 equal to 17?
Never.
Never. Not on days ending in Y. That'll be every day, but that's all right. 8 never equals 17, so this has no solution. I'm hoping some of you guys picked that up. Math has to have a way of telling me that my equation is crappy. Because in the real world, we're going to have equations. I'm trying to make this work, and it's just never going to work. Math has to have a way of telling me, hey, dude, that ain't never going to work. That is not going to work. That's how math tells me that. It says, okay, you write that crap down. I can say 8 is 17. I'm like, oh, shit, math. All right, you can't say that. No solution. Yeah.
Do you add? Like you're adding the plus sign?
Only if you're subtracting something, right? Like you subtract to get rid of addition.
But no, the plus sign, it says times 2, that plus that minus.
This here?
Yeah, plus.
So yeah, this is still plus.
So do we plus it?
So, but we're always trying to get x by itself. So we're always trying to get the variable to show up on one side. So in this case, I'm not just adding 2 plus 8. I'm actually doing something a little different, trying to solve this equation. And it has its own kind of way to do it. So hold on to that. How you guys doing? Okay. So the simplest example of this would be, now tell me what this equation is trying to say. Can somebody tell me what this equation says in English? And please don't say x equals x plus. What is this equation saying in English? There's a number that's the same as that number added 1 or increased by 1. Is there any number that's the same after you add 1 to it? Hell no. So we can see very easily, before I do anything, we know this equation is bogus. There's no way in hell to make this equation true. Are you guys with me? I could not just look at that equation and go, oh yeah, that's not going to be true, because I am not Rain Man. I'm okay with math, but I am not Rain Man. I had to do some work, and then I went, oh, that ain't going to work. Here, I know from the beginning, there's no number that is itself increased by 1. There's no way. Any number you take, add 1 is different. What's math say then? It's got to have a way to tell me it's crap. If I subtract x from both sides, what do I get? X minus x, 0 equals 1. There, that's math's way of telling me what I kind of already knew here. That equation is not good. It's never going to work. No solution.
No solution?
Yep. Because when can 0 equal 1?
1.
When does 0 equal 1? Never. Right? So there's no x that will make this true because it's never true. Yeah.
I don't get it. How come you can't, I'm not hearing you right or something. How come you can't have 5 equals 4 plus 1?
All right.
You know what I'm saying?
X equals x plus 1. X cannot equal 4 and 5. X equals one thing at a time.
Oh, because x has got to be the same number on both sides?
Exactly. If I said x equals y plus 1, which is something they'll do later in math, then they can be separate things. If I use the same symbol for it, it's got to be the same number. Is that cool?
I got you.
So that's a good point, though, yeah. So that's the point there. That's what you got to realize.
Why do you think y?
That's later. Later in this course, we're going to have 2 variables. Later. Don't worry about it right now. Don't worry about it. It's coming later. Don't worry about it now, Randy. Okay. So I wanted to close that loop and show you how that works out. Those of you that worked it out and got to something like this, you were fine. You just have to go the next step. If you stop here, that's freaking me out. Do you think 8 equals 17? Plus, my question would be solve. I need to see the answer. You need to tell me. No answer. Right? Okay, maybe. Now, let me see. Are there any questions on that? Or maybe some questions from homework? Yes, sir.
On that again.
What's up?
I know it's no solution because you can't take 8 equals 17.
Beautiful.
Because
That's it. So if you ever solve an equation and you get 7 equals 3, no solution. You know it's no solution. Yeah. I like it. Now real quick, before we get too far away from this idea, let me see if you guys are cool with this. What is that equal to if you just apply the right property?
2x.
And that's true for any x. I mean, that's just true, period. You're with me? So if I write that like it's an equation, that is always true. If you make x 5, this is twice 6. Right? If you let x equal 5, I get twice 5 plus 1 is 6. Is that equal to twice 5 plus 2? 12 equals 10 plus 2, 12. Check. Yes. Any number you plug in there is going to work because this is just distributive property. It doesn't care what x is. Distributive property works. It doesn't care what x is. So this equation works for all values of x. There's not a specific value of x. Shit, I erased it. There's not a specific value of x that will work. Not x equals 6. So somehow math has to have a way of telling me that the answer is all numbers. Any number is going to work in here. So if we start to work this out, distribute that. How do you get your x's together? What do you have to do to make them cancel here?
2.
Do what with it? How do you make them cancel?
1. X.
Negative 2x.
Yeah, subtract 2x. How do I make this become 0? Subtract 2x. And then what do you get? 2. That's math's way of telling me. When is that true? When is 2 equal 2? All the damn time, right? So then the answer to this one will be all real numbers. All numbers work. We just say real because we just work with real numbers here. There are things that are not real. We'll leave that for 103. Math 110, 103. Yeah.
I don't get it.
So remember this. Can 8 equal 17?
No.
So there's nothing that'll save this guy. Right? No solution. Look at this. Does 2 equal 2? Does 2 equal 2?
Yeah.
2 equals 1 is 2.
No, careful now. Think about it. Is 2 the same thing as 2?
Yeah.
Yes, so 2 does equal 2. Always. It's always true. So all real numbers will work. This equation is always true. No matter what x is.
So you can put anything in x. And
Yes, I love it. I picked one value, 5.
And then
If you pick anything, think of any number and put it in there, it's going to work. It's kind of neat. And you should realize, I mean, that's the way it should be. There are situations in life where no matter what you do, it's the same thing comes out. That's what math is telling you there. There are situations in life where you want to be somewhere and just ain't going to get there. That's what math's trying to say here, right? You want $1 billion for your little banana ice cream? No. There. Make 8 equal 17 and you got it. That's what math says. Okay. So what I want you to do now, and some of you guys are getting tired of this, but I really want to make sure we're all in the same boat. And I've got a bonus problem down here in case you fly through this. The bonus is a little bit freaky. So you can work together or alone on this. Were there any questions from homework before I get too far away?
I'm too stuck in.
Before I do that, then before I turn off my camera, where are we at with the homework?
So, 3.4, those
Three.
are problems that...
Oh,
Those,
we're not there yet. I haven't lectured on that yet.
Oh, I just want to show off that I'm at 3.4 right now. It's all right.
I got a question from 7-2. It's all right. Nope.
Oh,
Thank you. Yes.
Acts chapter 105. Chapter 105.
Chapter 1,
105.
page 105?
No, chapter 1.105.
Thank you. I'm not sure which chapter that is. Alright, so anything else from homework? Guys? Yeah. So we've officially lectured through section 3.3. Or I have. So I'd say, I know a few of you guys are still trying to get comfortable with solving equations. So I'm calling today the official day that we're done through section 3.3. So that homework will officially be due a week from today. Now, of course, remember, you always have until the day of the test, if you need it. But if you're done with through 3.3 by next Tuesday, then you're on track. You with me? 3.3. 3.3. You should have that done now. You. If you don't have that done now, it's too bad. Yeah.
So I'm stuck at chapter 2, 101.
Oh, okay. So you have to hold off on that because I got to focus on this for right now.
Okay,
Yeah.
sorry.
All right, here we go. So you can work by yourself. You can work together. You don't have to give these to me. We'll be going over them. Oh, okay. Hot fries. Are they hot fries?
Is that okay?
Yeah, next Tuesday, 3.3.
Yes.
What?
Friday.
I read.
Friday's like,
Yeah.
Whichever is more comfortable. You know, you're right there.